Okay, so this is how we write the equation of a line in space. Now you have to have two things. You need a vector that's going to be parallel to it, called the direction vector, and a point the line passes through. As long as your direction vector is not 0, 0, 0, then you have symmetric equations. Right, just solve for t in each equation.
Did you do it?
Yeah, I did it. It's in the top of the list.
Oh, I see. Okay, sorry.
Okay.
So this is distance from point to a line, and again, define the shortest distance from a point to the line. Relationships between lines, think back to geometry. Dealing in geometry had two possibilities for a line. Technically three. What were those three possibilities? Parallel, perpendicular, or the same. In space, we have a fourth possibility. None of the above. That's called skew. Not necessarily perpendicular, but I'm going to rephrase that. They intersect. Can intersect at any angle. And find an equation of a plane, so you need a vector that's normal to the plane. You need a point. You need 2 points in the plane. All right. And a vector in the plane. Right. Equation of a plane is a set of all points PQ, where n dot, the line segment PQ, is 0. That's the vector equation. We never use that. Standard equation, or scalar equation. We need the point in the plane and a normal vector to the plane. And that's your equation. That's called the scalar equation. We will generally just use the general equation. Ax plus by plus cz plus some constant d is equal to 0. And that constant is found as negative a times x naught plus, minus b times y naught minus c times z naught. Right. Distance between plane and the point, again, this is defined to be the shortest distance. You have two equations. First and second. Doesn't matter which one you use. They give you the exact same. Set of parametric equations for the line passing through the point and parallel to and line with the direction vector to -1, -4. Next essence, the plot line. antecedents, which points are included or are on the line. If we have let's bring this. Move. Okay, keep moving. And so let's call that our line. And we know the direction vector is parallel to any vector V. There's a line in question that tells us it's parallel to the given line L. What do we know then about the direction vectors? They have to be parallel. Every vector is parallel to itself, right? So why not just use the given vector as our direction vector? And we also have the point, so we have everything we need. AT plus X naught, or X naught plus AT. What was it in the definition, so I stick with it. Was X naught plus AT, so I can write it that way. Y naught plus BT, and Z naught plus CT.
What are
That's the parametric equations for the line. So that is how you would describe the line.
okay.
And T can be anything. Now I have to decide if the points are on the line. We'll start with that. 3, 1, negative 1. I guess that we're going to decide if it's on the line. Is there a parameter T that gives you X equals 3, Y equals 1, Z equals negative 1? Now, if Y has to equal 1, T would be negative, no,
Oh, it's just one.
yeah, T would have to be 1. Now, does that T equals 1 work for the other two?
Yeah.
It would have to, otherwise it would be on the line. A is on the line. Okay, very straightforward. Same game. I don't like working with fractions. T has to be what, negative a quarter? Two plus, or 1 plus 2 times negative a quarter, that's what, 1 minus a half, which is what, half? Two minus negative a quarter. 2 plus a quarter is 9 quarters, right? B is on the line. Oh, that y value is really nice. C's not on the line. A, B were on the line, C is not. Now just to plot it. This is a 3-dimensional line, so you're not going to be able to do it on calculator. Parametric plot. X equals 1 plus 2t, right? Y was 2 minus t. Z is 3 minus 4t. We obviously can't plot the whole thing. Pick a domain for t that you want to plot over. And that's technically all you need. And that's what it would give you. Yeah, I don't like that. Let's change some options.
So if you don't give it a z value, it'll just see this up to 10 or up to 20, I guess. Like the domain for z.
You can't pick a domain for z. The domain is for the parameter.
Oh, okay.
So then it'll just automatically set it. There is a way you can adjust it. There are options, I'm sure that'll allow you to do it. I'm not that worried about it. turn off the box and set the origin to actually be 0, 0, 0. Next, right now, if I just turn off the box, I think that point there would be the origin. And what you can do is you can actually rotate it. Not as nice as the desktop version, but it does let you rotate it. Unless you know how Mathematica works, I re-execute this. Which one's X, which one's Y, which one's Z?
Just right hand below.
Right, but there's 3 ways you do it.
Just ask us to label it.
To do the axis label. And I would probably also do this. Or if you even want to just keep normal size, get rid of the large. But at least make them stand out. And then you can just pick a suitable viewing window. So you can also do this. Viewpoint. Now here's the problem. Mathematica doesn't take X to be depth. I think it takes Z, no, I think it takes Y to be the depth, which is really odd. Right, so if I do front, it's viewing it from Y. So to get around that, use a right viewpoint, now it's going to view it down from X. As if you're standing in front of it. That's still not really that good, but at least it makes it easier for me to rotate it. Just rotate a little bit. Yeah, see, I don't like there. Just so you can more clearly see the x-axis. That'll work. And I'll go ahead and keep that hideous Mathematica color. Right, and then we can just paste it as needed, which I'm not going to worry about. Okay, but why is that now? What happened? Sorry. Equation of a plane passing through a point. That's the same thing as saying that the point's contained in the plane, right? And parallel to a given plane. Say that's the plane in question. there is the given plane that we know it's parallel. Call that the normal vector for the given plane. That's the normal vector that we need. What do we know about the two normal vectors? They don't have to have the same direction.
Perpendicular. Sorry, oh no, they're parallel, but they don't have the same direction.
They could or they could not. They don't have
They're
to.
in the same direction, obviously.
All we know is that they have to be parallel. The two normal vectors have to be parallel. Well, again, why not just use the given normal vector then? What's the normal vector? Just ABC. 3 negative 240. So our plane would then be given. That's the same. Now, plus a constant. That constant is negative a times x naught minus b times y naught minus c times z naught. Negative 3 minus 12, negative 15, plus 4, negative 11. That'd be up to me. In general form. Again, they want us to plot it. Oops. I'm going to try this. Plot 3D. So here's the thing with plot 3D. It has to be of the form z equals a function of x and y. So we have to solve the equation. This also has other problems with it. That is solving for z. Now I just need to put in viewing window for x and y. And again, I think that's all I need. I also don't know what it shows for z, but we'll find out. So the first thing I'm going to do is turn the mesh off. That just gets rid of the grid lines. I don't like the boxed. I never have. Even though whenever you look at a text, they always put 3D graphs in a box. Oops, that's one too many. Yeah, I don't like the Z because it's not really symmetrical. So I'm going to add two things, obviously my viewpoint, and I'm going to change my plot range. That's going to give me the Z axis. And that'd be looking straight at it in the front. Okay, so this actually didn't come up with any issues. So I'll just leave it. Oh, yep, there's the issue. So I never use it. Just that gray part there.
Is it because it's out of range?
Mm-hmm. Don't like that. So I will show you the way that I typically do it. Everything's going to be almost the same. I didn't think that. But I'll do this here. Copy that. Those options can be easy. Contour plot 3D instead. Now just enter the equation. And notice I'm using a double equals instead of a single equals. Single equal is saying it, it's essentially setting it, storing it as a value. A double equals is a test. So this is saying it's the set of all points where that is a true statement. Now I need to specify Z as well as X and Y. All the other options are going to be the same. And notice, that is just a quirk with plot 3D command. I don't know why it's there. I mean, I guess I kind of do to kind of show that it's cutting off, but just, no, I don't like it. I personally don't like it. And I'm not sure if it's present if you box it.
Please disregard all fire alarms. It is only a test. If you hear the alarm, please disregard. Only a test. Thank you.
Oh, okay. Because we gotta hope it's not a real fire that occurs during the testing. That would be bad. I guess I can find out. Let's just get rid of all that. Yeah, it's not there when you box it. Although, let me add back in the plot range. So adjusting that might. Yeah, it's still there even when you box it. If you adjust the plot range. Looks like if you just leave the plot range alone and let it choose it automatically, it won't be there. But that has, again, its own issues. I like adjusting the plot range. And there will be times when we need to. So I'll just default to the contour plot method. Plane contains 2 points perpendicular to a given plane. So come back to here. So there's our plane of interest. I'll say that is our given plane. And normal vector. Normal vector. Except here we also have 2 other points, P0 and P1. We're told 2 planes are perpendicular. So what does that mean about the normal vectors?
Zero. They should equal 0.
What about them should equal 0?
The cross.
Which says they're what?
If they're 0, they're perpendicular.
Your normal vectors have to be perpendicular. So we have to find a vector n perpendicular to n naught. But we know something else as well. How does a directed line segment P0, P1 relate to n? Why would you say parallel?
Sorry.
It has to be perpendicular. It's normal to the plane, so it has to be perpendicular to any vector in the plane. Or any line in the plane. So n is perpendicular to 2 vectors, so how do you find a vector that's perpendicular to 2 vectors?
Find the point that here, when you do the square root of all the vectors values, and like they're squares.
Cross the 2. You're looking at magnitudes. I'm not interested in magnitude in this case. Remember, it doesn't matter what the magnitude of n is. What matters is its direction. So you take the cross product of 2 vectors, does the order matter? Not in this case. All the order is going to dictate is its direction. 180 degrees. Either way, it's still perpendicular. So you could either do this, or this, or any scalar multiple of one of those two. As long as you don't change the direction except by 180 degrees. From here, we know what n naught is. And again, you can do either P0, P1, or P1, P0. The direction of that directed line segment doesn't matter either. What's that directed line segment? In component form. What is it?
23, 29.
We do the square root and everything.
No, 3 minus 1.
Oh.
Is what?
2.
What's the second one?
Negative 4. And then 2, negative, no, just 2. 1 minus. Oh,
Right, 1 minus 3 is what?
negative.
I'm also gonna factor out that. Right, here's why. Normal vector would then be yes. Remember with properties of cross products, in fact, it's scalar out. I can just drop that too. Because it's scalar, don't need it. Same argument, I could have just gotten rid of the 2 right here. Because again, I'm not changing the direction. You can change the direction of the plane by 180 degrees, but any magnitude will work as long as you have the same direction. So I could just drop 2 from P0, P1. I'm done. And not cross the new vector V, let's call it, right? But either way, the reason is the same. And you should take advantage of that to make cross products slightly easier. You don't want to be dealing with cross products with numbers larger than this. Let's see how good you are with cross products. What's that cross product? No, it took you too long.
I agree.
That's it, you're only dealing with cross products for one class, so you'll get faster at it. Because I think I saw 2 of you setting up the matrix.
Yeah.
Oh, no, I was just doing the, like, the multiplication thing. Just trying to-
I just set up the matrix in my head.
I tried to do it, but then like I got lost, so then I had to browse.
It's just a matter of doing it in your head very fast, or there's no fast way to do it.
That's,
That's just it. Okay.
you work with it so much that you can kind of visualize how it's going to work.
I understand.
I said, essentially, I have the formula memorized. But not because I actually memorized the formulas, because I memorized their method, and I can kind of set up matrices in my head and build them that way in my head.
Okay.
Right, sometimes I also just write, if it gets really long, I'll just write the vectors under each other, instead of setting up the matrix, because then it makes it really easy for me to see.
Right.
And then at that point, I know the determinant formula, because I've been doing it for freaking 30 years. That might be an exaggeration, but not that much. Be close enough, forgotten my work. And then I can just then do it in my head quickly. Again, unless the numbers are just absurdly large, in which case I'll then just default to a calculator.
Yeah, putting them on top of each other is a visual.
Because again, it's kind of like just setting up a matrix. Technically, we could factor scalar out if we wanted to, but we're dealing with fractions, and I don't feel like doing that. So So I'm just gonna use that as my vector. Also note you could use the opposite direction as well. So this vector, any scalar multiple of it, positive or negative, would work as your normal vector. But when you fully simplify the equation, it's always going to be the same. The 10x plus 7y minus 4z plus d. No good jokes. Okay. Negative 10 times 3 is negative 30. Minus 7 times negative 2 would be positive 14. So 30 minus 14, 16, and it's going to be negative. Negative 16. Minus negative 4 times 4. Be positive 16, right? That's not right.
See 12 times 1.
I'm looking at the wrong equations. Negative 10 times 1 is what I want. I want the point. I was looking at the normal vector. So that's right. Negative 10 times 1, negative 10. Minus 7 times 2 is negative 14. Right, so that's negative 10, that's negative 24. Minus negative 4 times 3. 12. Negative 24 plus 12 is negative 12. There's the equation. You should notice that we can get that form very easily from its scalar equation, just by distributing everything through. And again, you could also write d on the other side. I think that is the standard form. I think that's what it's called. If instead of it equals 0, it equals the scalar d, negative d, right? That would be the scalar form, or the standard form, I believe. So you may also see me write it that way, right? Say this equals 12. Doesn't matter, unless I specify which equation you use, it doesn't matter which equation you use. And I'm not going to worry about plotting it. And you already saw how plotting works in Mathematica. I'd literally set it up the exact same way, I'd just be changing the equation. So I'll let you do that on your own. I obviously uploaded the notebook files. Is this the first time we've actually used Mathematica in this course? So I'll upload the notebook file onto the SharePoint site. And then you can open it. I download it so you can upload it onto your cloud. And then copy and paste and change the equation to make sure you can get it. Right here. Here, want the equation plane, but we're only given points. I guess I didn't mention I've been using it. Standard notation for a plane is capital Pi. Standard notation for a line is capital L. And so that just represents a plane typically. Capital L just represents a line. So we have 3 points that we're given. But we have one of the requirements, we have a point. In this case, we actually have 3 points. But we still need a normal vector. How are we going to find it? Well, what did we say from last time?
The line is passed through like 2 points, and then we do that for like 2 sets to find out like doing the plot plane.
Would the cross of like PO, PTO, and then P
which I think is what you were getting.
Yeah.
The normal vector has to be perpendicular to all vectors in the plane. Well, we have 3 points, which means we can find 2 vectors. You don't want to use P0, P1, and P1, P0. That wouldn't get you anywhere. Because they're essentially the same vector. It's the same line. So that doesn't help. You need 2 separate lines. I think there's what? 3 pairs? Because order doesn't matter when you're dealing with vectors, when you're trying to find perpendicular. So you have P0, P1, P1, P2, and P0, P2. You just pick any 2 of those and take a cross product. Right? We know those 3 statements have to be true. So again, you just pick any 2 you want. What did I do? I'm going to stick with what I did. I did P0, P1, and P0, P2. What's P0, P1? I think we did that one already, didn't we? That was the same two points from the previous question. So I need to reinvent the wheel. Use that vector.
And drop the scalar, right?
I just dropped the scalar, right? Because I don't care about its length. All I care about is its direction. So why not make it as short as we can without involving fractions, which is what we did. Now we need P0, P2. What's P0, P2? In component form. Say it louder.
Stop calculating it in my head.
Cross product.
Yeah, cross.
Oh.
Not cross product right now. I'm trying to find P0, P2.
Okay. P2
Oh. -7 is it? Dirty POS. Now there's nothing to factor out. I can't shorten that without involving fractions, which is worse. Bummer. Now we have our 2 vectors. And is their cross product. 14 minus 2 is 12. -4 plus 7 is 3. -2 minus -8. Yep, okay, my notes must be wrong here. Yeah, I must have not known how to do arithmetic. That's -2 minus -8. No, that's right. I got it right. 6. Again, the length of the normal vector doesn't matter. All that matters is its direction.
Wait, for P0 and P1, are there 2 vectors?
You cut the scalar. You
I
cut it out.
I cut the length
Cut the length one.
because it had a common factor of 2,
Oh,
so I just dropped it.
oh, I see.
Right? Because again, I don't care about its length. I just care about its direction. So if I can get rid of that common scalar, why not do it? Or just shorten it, but not change its direction. And that's the same thing as what I just did for n.
Right, yeah. Okay.
All I did was shorten it. The only time you can change its direction is again if you flip it 180 degrees.
And flipping it is just
Multiply by a negative.
-1.
So I could have also factored out a minus
Yeah.
and drop the minus if I wanted to. for x plus y plus 2z, now we need to find d, right? Negative, doesn't matter which point we use. No, as long as it's in the plane, doesn't matter. Oh, one of the points has a 0. I'm gonna use that one. Negative 4 times 5, negative 20. Negative 2 times negative 4 is 8. So it's negative 20 plus 8. Negative 12. Favorite plane. And it doesn't matter what point you use, you'd always get negative 12.
How are you getting negative 12 here? We just.
The normal vector times.
So pick a point first.
Okay.
We'll just say it's x naught, y naught, z naught.
Yeah.
Your normal vector is a, b, c.
Yeah.
Negative a times x naught minus b times y naught minus c times z naught.
Does the sign also flip because, like how we did it in the matrix? Like, you know how it's like.
What do you mean does the sign flip?
Because you said negative and then.
No, it's because, if I go back to the scalar, distribute. Notice that all of your points are minuses.
Right.
That's why all 3 of them have to be negative on that one side. Now you can move it to the other side and then it's all positives.
Oh.
Right, then you don't change the sign.
Right.
Right, so you could do that as well. Or you could calculate that without changing the signs and multiply by minus 1. Right, that also works. Because you can factor out that negative, right? Right here. You can just factor out a negative from that. Do ax naught plus by naught plus cz naught, and then multiply the whole thing by minus 1. Either way, doesn't matter. Good? Shortest distance, which is by definition the distance, from the point P and the plane 3x minus 2y plus 5z minus 10 equals 0. Except I don't want P naught here, I'm going to use P because that's what they gave us. Distance is the component of QP onto N, where Q is any point on the plane. Remember that is magnitude of its projection. And we know the formula for projection. I think I did that backwards. Right. Which we can simplify. That's the absolute value of n dot qp divided by n. All we have to do is find our point Q. Now remember, it can be any point on our plane. If x and y are 0, what does z have to do? So there's a point on the plane. It's not the only point you can use. Any point that satisfies that equation would be on the plane. So generally speaking, what you do is you just pick 2 variables, assign them a value, and solve for 30. Component form of QP. Remember, P is now your terminal point. Q is your initial. Be 1 minus 0, 2 minus 0, 3 minus 2. What's the normal vector?
Wait, how does yours come 0, 2,
Hmm?
How do you get 1, 2, 1, 8?
QP, 1 minus 0,
2 minus,
2 minus 0, and wait, minus 2.
Should that 1, 2 be negative?
no, because,
No.
P is.
P is the terminal point.
Oh,
Q is the
so
initial.
it's the other way around.
That's why I said, pay attention. If it was PQ, then it would all be negative. What is the normal vector? You know,
I think 0, 0.
vector normal to the plane. You're overthinking it. It's just your coefficients of the variables.
Oh,
And by the way, I didn't have to actually use this form, right? I could have used the second form that was given.
the absolute value.
Now we want n dotted with QP. Right, so it's 3 minus 4 is negative 1, plus 5 is 4. Over magnitude of n. 9 and 4 is 13, and 5 is 18. Square root of 18. Oh wait, is it 18? No, it's not. 9 and 4 definitely 13, but it's not. 5 is 25, 38. Square 38, that would be what, 2 and 19, nope, bummer. Four over 38 is your distance. Which could simplify if you wanted to. Want to write it where there's no square roots in the denominator. That'd be what, 2 root 38 over 19? I think the 4 over root 38 looks simpler. That's just me. Right, at this stage, you should know that you're lied to in algebra, right? You're allowed to have radicals in the denominator. That's not actually a mathematical goal. They lied to you just so you do it and get practice at it.
Wasn't it because back in the day we couldn't like do it in calculators when it was on the denominator, like a radical?
Oh, I have no idea. I just know they lied to you. Or else I remember back in the day there were no calculators.
I mean, like
They
on
used
that,
abacus.
that.
Oh, those things are fun.
Have you seen some of the competitions? They're just like,
I just look at them they're useless skill. That's where my physics comes in. Remember, that's such a useless skill. And then my math side has to compete. Go, who cares? It's cool. Because that's the difference between physics and math. Math, we don't care. if it's useful. It looks cool, so we study it. Was it useful? Who cares? Physics, we care about how it's used. We go with the practicality. Questions? So that's just lines and planes. I kind of broke the analytical study of space into two parts. Your textbook, I believe, I think your textbook does split into two. I think it does lines and planes as a section and then quadratic surfaces as a section, which is good. Because I'm going to study quadratic surfaces next, but I don't go as in depth. I'm doing two at once. I'm going to just kind of introduce some of the surfaces and then move into the cylindrical and spherical coordinates. I won't really do any kind of work with quadratic surfaces. That is going to be left for the homework. It's real simple. Also, the really astute of you should have noticed I uploaded 4 files, blank files onto SharePoint. You can print those out and use those on any test.
It's a zero corner.
Yeah, you have a table of integrals, table of derivatives, a review of precalculus table, and also a basic functions.
Yeah.
Those two are kind of the same, it's just the basic functions gives more trig identities. I really like that one. But it doesn't have everything that the review does, so I just put those up there. Also, speaking of that, I meant to hand this out last week.
It's a cheat sheet, right?
This sheet, double-sided, you can write anything you want on it to use for the first exam. The only restriction you have is it has to be handwritten. And you can't type something up and then put this into your printer. It has to be all handwritten. Do not lose it. It's the only one you're getting. And this is the only reference sheet that I will allow on the exam. Minus those formulas, minus those tables that I posted. So you can't use like a loose leaf paper to write as a reference sheet. I won't allow. It has to be the screen sheet.
Which I used our first exam.
There you go.
No, 30th. It's before the 30th.
Okay.
I don't
Okay.
remember the exact date. It is on the syllabus. It's coming up though.
Yeah, I know.
It's not
before-
next week. I think it's the
before
week
the
after.
assignment. Yeah.
I think it's the Monday after next. So again, third homework is now up. Third homework is longer because it's covering, well, technically 4 sections, 3 topics.
So it's gonna be like 30 questions. 30. 27.
Well, 27, but you only have to answer 5 in each grouping. No, it's covering 4 sections.
No, but like, first, like, get credit.
You have to answer 20 correctly to get credit.
Oh, 'cause it's 4.
I split it by
Oh,
section.
I see.
Because I'm combining surfaces and cylindrical and spherical into one meeting today, but that's 2 sections that's being covered. Continue working on that first group assignment. That is due the 30th. Because that goes up through motion in space, but the first exam stops just before we do motion in space.
On the homework, the accuracy for the questions are like by 0.01. Is there?
It depends on if it wants it to be exact or not.
But
So if someone's already going to email me, I'll look into it. but it should be a 5 plus or minus 5%
Okay.
accuracy.
Yeah, we're getting.
Unless it wants exact. If it's exact form, it won't tolerate any accuracy.
It's not even form, it's like decimal points, like. if it's
Yeah,
off
that's
by-
not so bad.
Right, but if you're approximating what should be an exact form, it's gonna work it wrong.
No, because like in some of the questions, it says like,
Right, so for instance, 0.33 is not 1/3.
Right.
So if it wants 1/3 and you put 0.33, it's gonna work it wrong.
No, it's like,
We can, I think. we
But I'm
can
just,
go to-
I'm using that as a simple example.
yeah. But,
It's more of like when they're asking us to calculate like exact like force values, like with
So, like,
equivalents, it specifically asks like to round it to like the nearest hundred or something. We would be off by one.
Then you have to message me.
Okay,
Message me the problem.
got you.
Because I have it set at 5%
I
tolerance.
see. Okay, yeah, that was more what we were trying to.
I have it set to be 5% tolerance. So it should accept that, but I'll let you decide.
yes.
And the first quiz posts today after class. 3:15 is set to post, and it'll be due before our next meeting. Right, and the quiz only covers up through what we did today.
so,
And all quizzes are non-comprehensive. So the next quiz would pick up with what we do next. And go up through what's covered for that quiz. Which will be before the first exam. So your second worksheet. And you will then have 30 minutes to work on that. And that will be the rest of the class, right? So when you finish,
yes.
Yeah,
That way.
yeah.
Are you scared? Yeah. Are you scared?